Hi guys, my name is Harry. In this lesson, we're gonna learn how to find a solution to a non-homogeneous, nonlinear, second-order differential equation, and as well as how to find a solution to the corresponding initial value problem. The question reads as follows. Solve the initial value problem by finding a general solution of the differential equation given that y1 is equals to x is a solution of the complementary equation x squared y second derivative plus xy first derivative minus y is equals to 0. The given differential equation is x squared y second derivative plus xy first derivative minus y is equals to as x squared plus 1, and initial conditions are given as y of 1 is equals to 1 is equals to 2, y prime of 1 is equals to minus 3. We are going to use the method of reduction of order to find the general solution to this differential equation, and then from there continue and solve the corresponding initial value problem. By method of reduction of order, we firstly gonna assume that our general solution y of x is in the form u of x multiplied by y1 of x. Therefore, the general solution y of x will be equals to u multiplied by y1 of x, which is simply x. Now we're going to continue and find the first derivative and the second derivative. So the first derivative of y of x will be equals to u prime of x plus u. And then the second derivative is going to be u double prime of x plus u prime, and then plus u prime. And this is going to be equals to u prime double prime of x plus 2 u prime. Therefore, the next step, we're going to substitute our y of x, y prime, and y double prime into the given ODE as required, so that we can be able to reduce the ODE into a first order linear differential equation. So let's continue and do that. The ODE is x squared y double prime plus xy prime minus y is equals to x squared plus 1. So when I have x squared multiplied by y double prime, which we found to be u double prime x plus 2 u prime. And then this is plus x multiplied by y prime, which we found to be u1 of x plus u minus y, which is u of x. U multiplied by x. And then this is going to be equals to x squared plus 1. Now let's continue and multiply out the brackets and then solve for the common variables. So we're gonna have u double prime x cubed plus 2 u prime x squared, and then plus, we do the same with the x, we multiply it with what is inside the brackets. So this will be u prime x squared, and then plus u multiplied by x, and then minus u multiplied by x will be equals to x squared plus 1. And then these are like terms, they will cancel. Then the resulting equation will be u double prime x squared. We also have other like terms here. So this is 2 plus 1, which is 3. So this will be plus 3 u prime x squared is equals to x squared plus 1. Now we can divide everything by x cubed. So we have u double prime, and then this will be plus 3 over x, u prime is equals to x squared plus 1 divided by x cubed. And then we have a second order differential equation. Now we're gonna let choose any variable. I choose z, and I let it to be equals to u prime. So by doing so, I'll be able to reduce this equation to a first order differential equation. So since I did let z to be equals to u prime, that means z prime will be equals to u double prime. Therefore, we're gonna have z prime plus 3 over x z, it's equals to x cubed, x squared plus 1 over x cubed. Now we have a non-homogeneous linear first order differential equation where our f of x is x squared plus 1 divided by x cubed. So since this is a non-linear, it's a non-homogeneous equation, we're gonna use the method of integration factor in order to find the general solution to this linear ODE. So let's continue and find the integration factor. So the integration factor is going to be given by e to the power integral of 3 over x and then dx, and then this is going to be e to the power. The integral of 3 over x, this is going to be 3 multiplied by the line integral of 1 over x, which is simply ln of x. Therefore, we're going to have this to be e to the power ln of x cubed. Thus, our integrating factor will simply be equals to x cubed. Now, let's continue and find the general solution for z. So z of x will be given by 1 over the integration factor, and then into the line integral of the integrating factor multiplied by f of x dx f of x dx, and then plus c. Therefore, this is going to be equals to c of x will be equals to 1 over x cubed into the integral of x cubed multiplied by our f of x, which is x squared plus 1 divided by x cubed, close bracket, dx, and then plus c1. Therefore, this is going to be equals to, I can write this as x to the power minus 3. Then into, we can notice that x cubed will cancel x cubed. So I'm just left with the integral of x squared plus 1 dx. Then plus c1. Thus, the c of x will be equals to x to the power minus 3, then multiplied by the integral of x squared, which is x cubed, divided by 3 by the integral of 1, which is simply x, and then plus c1. Therefore, c of x will be equals to, and then we multiply this by what is inside the brackets. We multiply x to the power minus 3 with all variables that are inside the brackets. So this is going to be 1 over 3 plus, and then x to the power minus 3 plus 1, that is minus 2. So this is same as plus 1 over x squared, and then plus c1 over x cubed. Now, since in the beginning we did let z to be equals to u prime, we can therefore say u prime of x is equals to 1 over x squared plus c1 over x cubed plus 1 over 3. And then u prime of x, this is du over dx. It's going to be given by 1 over x squared plus c1 over x cubed plus 1 over 3. Then, by separation of variables, we're going to have du to be equals to 1 over x squared plus c1 over x cubed plus 1 over 3 dx. From there, we integrate both sides, and then we're gonna get that u is equals to the integration of 1 over x squared. That will be x to the power minus 2 plus 1, which is minus 1. So this is basically going to be minus 1 over x. And then from there, the derivative of c1 over x cubed, this is x to the power minus 3 plus 1, which is minus 2 divided by minus 2. So this will be minus c1 over 2x squared. And then plus the derivative of 1 over 3, that is basically 1 over 3, the integral of 1 over 3, that is 1 over 3x. Then from here, we're gonna add also the constant term. Therefore, this is our u. Let me say u of x, because this is a function in terms of x. Now we can continue and find the general solution. Remember, with method of reduction of order, we firstly assume that our solution is in the form u of x multiplied by y1 of x, which is then basically given by u of x by y1 of x, which was given to be x. Therefore, that means our general solution y of x is going to be given by minus 1 over x, then minus c1 over 2x squared plus 1 over 3x, then plus c2. Plus c2, this is multiplied by x. Then our general solution y of x is going to be equals to, we gonna multiply our x with everything that is inside the brackets, right? So let's continue and do that. X minus 1 over x multiplied by x, that is minus 1. And then the second term, we're gonna have minus c1 over 2x. And then the third term, we're gonna have plus 1 over 3x squared. And then the last one, we're gonna have c2 of x. Then let's rewrite the equation. Y of x, let me use a different color. I prefer black. So this is going to be y of x is then equals to c2 of x minus 1 over 2x c1 plus 1 over 3x squared minus 1. And this is the general solution to the given non-homogeneous nonlinear second order differential equation. So we can now continue and solve the initial value problem. So we are given that y1, the initial condition y1, y of 1 is equals to 2. So we're going to have 2 to be equals to C2 multiplied by 1 minus 1 over 2 multiplied by 1 C1, and then plus this is plus 1 over 3 into 1 squared, and then minus 1. So let's punch on a calculator. We're going to have 2 to be equals to C2 minus C1 over 2. And then we have 1 over 3 into 1 squared minus 1. So this is minus 2 over 3. Therefore, 2 plus 2 over 3 is 8 over 3. So we're going to have 8 over 3. Then I will say, let me take C1, half C1 to the other side. So this will be plus C1 over 2. Then is equals to C2. Then we can call this our equation 1. And then to find our equation 2, we're going to find the derivative, the first derivative of our general solution. So let's find the derivative, the first derivative. So the first derivative, it's going to be given to be equals to the first derivative, it's going to be equals to C2, and then the second one is going to be minus 1 over 2. Then we have 1 over x, that is x to the power minus 1, so that will be minus 2. So this is basically 2x squared, and then this will be a plus, and then this is multiplied by C1. And then for the third equation, we have 1 over 3 x squared. To be clear, we have 1 over 3 x squared. So the derivative will be, it's a plus. So this will be plus 2 over 3 x, and then minus 0. So this is the first derivative. And then now we're gonna substitute our initial value. So let's go ahead and substitute our initial value, which is given to be y prime of 1 is equals to minus 3. So this will be minus 3 is equals to C2 plus 1 over 2 into 1 squared. 1 squared is 1. So this will simply be 1 over 2 C1. Then plus 2 over 3 into 1, which is 2 over 3. Then we'll have minus 3 minus 2 over 3. That is minus 11 over 3. And then I can have this by minus C2 is equals to C1 over 2. So previously on our first equation, we got that, was that equation? We find out that after substituting the initial value, C2 is equals to 8 over 3 plus half C1. So let's go and substitute it. 8 over 3 plus half C1. So this will be minus 8 over 3 plus half C1 is equals to C1 over 2. And then we're going to have minus 11 over 3 minus 8 over 3. That is going to give us minus 19 over 3. And then minus 1 over 2 C1 is equals to C1 over 2. So minus 19 over 3 will be equals to 1 over 2 to the other side plus 1 over 2, which is 1. So that is simply C1. So C1, the value for C1 is minus 19 over 3. Then for C2, the corresponding C2 is going to be equals to 8 over 3 minus 1 over 2 into C1. Yes, I believe that is the correct equation for C1. Yes, it's 8 over 3 or plus 8 over 3 plus 1 over 2 into C1. And I'm getting C2 as minus 1 over 2. Therefore, the general solution is then going to be y1 of x y1 of x is equals to, we found our C1 to be minus, so this will be plus 19 over 3 19 over 3 multiplied by 1 over 2x, and then for C2 we have plus minus 1 over 2 multiplied by x, and then plus 1 over 3 x squared minus 1. Hence, the final solution to the initial value problem, y of x will be 1 over 3 x squared minus 1 over 2 x, and then 19 over 3 multiplied by 1 over 2, that is plus 19 over 6 x, and then minus 1. Is there any term that I left out? There's no any term, and this will be the solution to the initial value problem.